Hi, I'm Vicki Snelson of the Rock Mechanics and Explosives Research Center at the University of Missouri-Rolla. In the summer of 1982, we began a series of tests for the Naval Weapons Center of Crane, Indiana. These tests were to look at the possibility of using high-pressure water jets to clean the explosive from missile casing. About this time, we had a visit from Mr. Hubbard of the Rarty Group in England, and he showed a videotape in which the entire explosive reacted, as well as shots of different tests where only small surface reactions occurred. Looking at a copy of that tape, these tests use half-inch jets of water. For the first test, the explosive is on the right and the jet comes from the left. For the second test, the explosive was centered and the explosive reacted. The explosive was then moved back to the right of the picture, but while all of the tests showed reaction, it was so small and the event was so quick that it cannot easily be picked up from the videotape. If therefore we instead look at single frames from the film, we can see for the first shot that there is a little spot of white showing a reaction as the jet begins to hit the explosive. For the second shot, the frame is whitened out by the reaction of the entire explosive charge. For the third shot, we again have single spots of reaction on the face of the explosive. And similarly on the fourth test. The fifth test, and the sixth test, which were carried out. Our first step has been to try a similar type of test for the explosives we are looking at. In order to get this reaction, we have designed a system to move the jet at around a mile a second. Mr. Hubbard indicated that he was getting a reaction at 1.6 kilometers a second, and our jets must therefore move at that same speed or faster. To provide the force to move the jet that fast, we have used a precision blasting cap like this. It is placed in a special container which fits into a retaining block. In front of that cap, we then fit a small rubber washer and then fit a water jet nozzle, which is held in place by a large bolt. The entire mechanism is then fitted into the main body of the device. The whole unit is put together and then placed in the explosive chamber. Approximately 1 cc of water is then carefully loaded into the nozzle of the device using a hypodermic needle, and a small piece of explosive is set in a holder above the nozzle. The main door of the chamber is bolted into position. During the test, the water gun and the target explosive are observed through special ports in the side of the chamber. In order to see the test, we have connected the explosive cap to a cordon framing camera and thus can photograph the event at speeds of over 100,000 frames a second. At the same time, we monitor the event with a spin physics video recorder, which takes pictures at 12,000 frames a second, since the cordon can only take 25 pictures, and we may thus miss some of the later events that might occur.
Okay.
Only now is the power supply switched on. And as the camera is brought up to speed, derringer has been fired. The spin physics camera picture shows first the setup with the scale and then sets of 6 pictures as the event occurs. These frames are at a rate of 12,000 frames a second and are taken from the top down. In the frame are 6 separate pictures. The jet was moving so quickly, however, that the event occurs on only 2 frames, and it is difficult for us, since we have just received this camera, to capture all the information. On the other hand, looking at the frames of a record taken at 200,000 frames a second with the cordon, and with the markings being at 1 centimeter intervals, sequential frames show that the jet is moving at around 2 kilometers a second. The jet is much smaller than that used by Mr. Hubbard, and it was not possible to see any reaction from front-lit pictures because of the lack of contrast. When the scene is lit from the back, however, some small amount of light can be detected around the impact point on PBXN6. There were definite signs that there was a reaction on the surface of this explosive after the test, and we are still looking at the results and running more tests in order to better define what is actually happening. Because the jet is much smaller, we are not sure that we will get the same level of reaction as was obtained at Rarity. We are, however, continuing the test series, looking at the different explosives and changing the diameter of the jet. Later we will try and move it a little faster. For the present, it would appear that, for this jet size, that a 2-kilometer jet is just starting to cause a reaction. We hope you will be able to join us again when we report on the result of those tests. Thank you for watching, and goodbye.